Alright, in this video, I'm going to run through the calibration procedure for the CylinDraw. This is the device that we built in the last video, which was about 2 hours, the physical assembly. It's almost completely done, but it needs to be calibrated so that the machine knows that it's where everything's positioned, that it's going to operate the way that it's intended. I'm going to run through some software setup and hopefully preemptively answer any troubleshooting questions you might run into. I'll show you my screen. Now, I'm going to recommend you get started by going to CylinDraw.com with the Downloads tab, and you can get the software here. I have a 64-bit system, so I'll get that one. Let's see, I'll show you how to check, actually, what type of system that you have. You go to this PC on your Windows PC, you right-click and go to Properties, and where is it at? There we go. 64-bit operating system, right in the middle of the screen there. And at this time, we're only supported on Windows at all. So that's, if you have Linux or anything, we're not there yet. You download it, you unzip the package. This is what you're going to find, all this stuff. I'm going to open. Oh, let's see. Let me make sure that it's physically connected before I do all that. Okay. So on the back of this device here, there's power connected to our power supply and our switch. There's a little 0, that's off, so I'm going to power that on. And then I've got USB with a extension data cable going into my computer, and that's all the cables that go into this. So I'm going to open runmode.exe. Now, if this file doesn't open on your computer, I'm going to recommend you come back to this downloads page. And where are we at here? Recommended third-party software. This software runs on Java, so there's how to install Java on your computer. And I'm going to flip back to this page in a second here. So I've plugged it in. It says USB connection found. Now, if I unplug it, there's no Arduino. The computer says, oh my God, there's nothing here. It's checking continuously. If you have your Arduino plugged in and it's still doing that, we're going to need to, well, there's different ways, different side effects of it having improper drivers that can result. But if you think you're connected right and it's not working, come back to the downloads page and go to this link here, Arduino chip drivers. This is software you install on your computer so it knows how to talk to the Arduino properly. And there's also, so it's an Arduino Nano. There's different revs out there. There's all kinds of stuff that looks like it might work. I can't even promise that those would work. Use this one because this is the one that matches what the manufacturer had. At that link is a link to a SparkFun page. You scroll down and here's Windows EXE. You just run that and you're done. Let's see. Actually, let me think about it. That might actually install that on the Nano. In either case, have it plugged in and run that. So it's plugged in, it knows it exists. I'm going to go up here, this little button, this is the only time you're going to use calibration mode is just in this instance. It says run motor calibration, I click it, make sure that you can, yeah, okay. And then I'm going to go to, let's see, now it defaults to automatically connecting to searching for whatever Arduino it can find on your USB port. If for some reason it's not working still, you can go to help. And here we have an option to auto USB connect or manual. You can pick manual. And I've also got show G code. This is like background code, the commands that it's sending back and forth. You don't need to see that, but during this procedure, it's useful to see that for troubleshooting. So both switches are to the right, manual. Let's see, now that it's manual, I'm going to click the manual USB connect button up here. And it only sees one Arduino or one device on there that it recognizes on here. So boom, good. And it gives me a happy little beep. If it does any beep whatsoever, that's also good news because that's run by the firmware that's on the Nano. So if you're like wondering if it's got the right firmware revision or if it's on there at all, you hear beeping when it has power, that's good. That means it's on there and that your beeper is connected too. All right, so I'm just going to start with test number 1. Test 1, check pin carriage motion and positioning. It's just going to lift and drop this a few times. Let's see, pass criteria, troubleshooting. I'm going to take off my pen here because in the last video, I never actually screwed on the servo horn, and this is why. Poof, so it's not, that's where it lifts it up and down, and it's not going to do anything. I'm going to hit cancel real quick, and I'm going to go to Tool, let's see what I want it to do. I want it to be in this flat position, so I'm going to say Tool down, and now the computer, the servo, everything's aligned. It says this thing needs to be down right now, so I'm going to attach the horn now in the leveled off position so that everything will match up. Let's see. Get my head in the camera here. Servo down. I'm going to position it as close as possible to touching that surface without actually touching that surface, so I'll get as much range of lift action as possible out of the servo. Let's see. Pause it while I fumble around. Oh, that's interesting. Alright, I had to do that. I paused it for a second because I realized this little commodity part here, a minor variation, I actually had a horn that was just a couple millimeters longer than the other one that this was designed around. So I clipped off the end a little bit so it would physically fit in there. But it's all good. You only have to do that once and it stays in there. Flip back. Oops. Flip back here. So now it's screwed on there. I do tool up. And it goes all the way up. So it looks great. So I'm going to hit test number 1 now. And all this test is moving it up and down a few times. And every single time the carriage needs to actually come down on its own smoothly. We're looking for stiction here. If these things are too tight on both sides, then it could stay up and gravity won't pull it down, and then it's not going to work whenever you're trying to draw with your pen. If that does happen, what's likely is during the assembly process you've probably tied the zip ties down too tight. It's only meant to have 3 on the same side tightened all the way, and then the other side they're very loosely attached, so this is fixed and this is kind of an anti-rotation on that side, and that's all it needs. But at the same time, once you get it right, like that's rock solid on there. So test 1's a pass. On to test 2. Verify the stepper motor direction. Move the pen carriage to the middle of the cup. I've got my motors activated. Hit cancel. I'm going to kill my motors. Now I can push it. Move in the middle of the cup. The linear motor, H-axis, should move up the cup. That way, the rotary axis should roll away from you where you're standing in that position. So that way and that way. Hit it. Cool. It just does it a little bit. This is to prevent crashing anything, and it worked good. If it did not, if one of them went the wrong way, so let's say if this axis spin toward you, you're going to need to power, physically unplug the power from everything, open the lid, and then go to that motor's driver. So the rotary axis is the one all the way on the left. In fact, that's the rotary axis, and that's the linear axis. You pull. What am I thinking about here? Oh yeah, you pull the motor cable off and flip it 180 degrees and put it back on, and that'll flip it. But you don't want to do that with the power attached, because that will burn something out. That's just inherent to the hardware. So that passed test 2. On to test 3. We're just checking that the homing switch physically works before we try to actually home. So we hit OK, and what this is going to do is it just primes the button to react whenever I press it. Cool, it works. And I gave that 10 seconds to respond that way. And on to test 4. Verify the repeatability of maximum and minimum extended the positions. So it says install the pin carriage and cup. Put this guy on. Get that out of the way. I got the paper cup it comes with. Definitely use that for this in the next test. because the software comes with some built-in defaults for the next drawing that you're going to want to use. They're sized for this cup. So put that in. That's good. Lift this up. Align the axis with the surface of the cup close enough. Tighten it. And then I'm going to kill those motors. Loosen them so I can spin these two discs relative to each other and get a good grip. And just get it snug. And actually, that was part of the part of this test here. So I'm going to put this pin in. The lifter is lifted, so I'm going to put it in so it's just off the surface of the cup by up to half an inch. I usually just kind of shoot for the middle there, right in a quarter of an inch. And I'm going to manually move this over towards home. Now, the idea is this slider on the back, right here, I can turn the knob and move this slider. The slider is what touches the end stop. And what I want is for the pin tip to be aligned with the exterior surface of these knobs when the button is pressed. That's your home position right there. So that when you click home, no matter where this is, the tip will not touch a knob that it's not supposed to. So that's what it calls home. Like so, right about there. So I'm gonna leave it there. Loosen this, push it, click, and then tighten it. And test number 4. And now it's doing a pin change prompt. Oh, look at that. So I've got it set. I'll have to troubleshoot that at another time. It's expecting the cup to be taller with my, that's a hard-coded setting in the firmware for what distance to go to. And what you were checking for is that there's not multiple locations of dots anyway. And there wasn't. It started and finished at the same spot both times, so nothing's loose is what that's checking. I guess no harm done that it didn't actually draw on the farther one. In any case. And now test 5. We're going to verify drawing speeds by drawing a nested square. It's 50 millimeters. Do it. Oh, do that. So on this, what I'm going to measure is this line right here, this line going that way, not the line that wraps around the cup. Check it's 50 millimeters. That looks good. If it was off, it'd probably be off by a lot. So excellent. Passed all the tests. We're ready to go. And while it's locked in there to the center of that, I'm going to hit rotate cup 180. So now I can do my business on the other side. Go back to run mode. Check here. So now run mode, I'm still on, let's put it on auto USB connect, and it's going to hide the G code. You don't need to see it. And I'm going to hit play. It's already preloaded this job. I can click it here. Click it right in the middle of the screen. It'll load up CylinDraw viewer, which can show you, if you're interested, exactly what it's going to do. I can look at all that stuff, and you can also hit view details, and that'll launch it in your in your internet browser, so you can see all the details of the SVG file that was created with. And just hit play. Now, on that last test, if you notice that the square was not 50 millimeters, I was just talking with somebody recently where their square was drawn much shorter on the linear axis. We determined that we forgot to adjust the jumpers on the y-axis stepper driver. So I'll just do that to show you what I'm talking about. I got those. I'm going to note the orientation of that because it can fit in both ways, but only one way is correct. Take it off. Oop. So I'm going to take off on the y-axis the bottom and the top jumper and leave the middle one. So that's hard coding. It's hard setting the micro steps, the step resolution on this board. And the reason I do that, I don't go ahead and use all the steps for the y-axis, is because I'm trading some resolution I don't need for speed that I do need. And I'm going to pause it for a minute. There, cool. So I noticed this felt tip pen on the paper bled pretty badly. This is really good for plastic cups, so probably a regular ink pen would have worked a little better for that. But that's what it looks like when you're done. It passes all the tests. And I guess while I'm looking at it, we can check out the rest of this stuff. So there's, let me see here, kill my motors. You can go to update speed if you wanted to set a different drawing speed. 50 is good for, so I show you in there the defaults that work. You can experiment with some insanely high stuff. It will attempt to do it. You can, if you don't like the beeping at the end of jobs or to prompt you for tool changes, you can hit quiet mode. And then there's also, let me get this out of the way just in case. You can set it to roll forever. And you can adjust that speed in this in that window. Where'd it go? Why am I not? Oh, travel speed, because it's up. Anyway, if you're gonna like brush code on or something like that, sometimes that's just useful. You can click it again to change the direction. And that's what this program does. And I think I'll save a future video for covering the other modes. So I hope that gets you going. Thanks for watching.